So welcome you all for the today's session on a practical guide for beginners in data science. Lecture 9, copying arrays, array shape manipulation, identity array and I function. Copying arrays. So this command, so it is not going to make any change to the original array, but the changes will be reflected only in the copy. Now we'll just move on to the command import numpy as np. Array is equal to np dot array. So it just gives prints the array 1, 2, 3, 4, 5. Now I am making a syntax called, I am just assigning a variable x is equal to arr dot copy. Okay, so whenever I am going to give this command, so the array is going to get copied to a variable called x, in which array of 0. So 0th index is going to be replaced as 42. That is this data 1, it is going to be replaced as 42. Now I am giving the command as print array. So now in this array, the 0th element is changed. So it will be changed and shown in the output. The next thing I am printing the original array, print x, it is going to print the same. So the original array is going to be retained as it is, and the changes are going to be made only in the subsequent copied array. So the next command is array shape manipulation. So what do you, first of all, let us know what is reshaping. It is means that from the name itself, it is evident that we are changing the shape of an array. Okay, the shape of an array means that is we are going to meddle with the number of elements. Okay, we are just going to change the number of elements in each array. So by reshaping, we can change the dimensions of the array. Okay, now we'll just see an example of how to reshape an array from 1D to 2D. Okay, array is taken np dot array, elements are from 1 to 12. Now the new array is given, that is arr dot reshape 4 comma 3. That means you are going to reshape the existing array in terms of 4 rows and 3 columns. So now it is in terms of 4 rows and 3 columns. So the command used is arr dot reshape. Okay, now we can use some other commands also to execute the same work. For example, flattening the arrays. It just converts a multidimensional array to a single D array. So reshape, what we have seen, it converts a 1D array to a multidimensional array. So for this, we can also use the same reshape command. Okay, that is reshape of -1. So a array has been taken, a 2D array. Now I am giving arr dot reshape of -1. So when I give this, it just flattens the multidimensional array into a single dimensional array. Now there are certain other commands what we can use is arr dot flatten, arr dot ravel, then arr dot reshape. So either of the commands could be used for array shape manipulation. Next, we'll move on to your identity function. So in certain places, we just want the diagonals alone, we should have a identity matrix. Okay, so all other places it should be 0. So the command what we are going to use is np dot identity. Okay, so import numpy as np dot identity of 2. It just creates a matrix, okay, a array of 1 on the main diagonal and 0 on the remaining places. And if I'm not giving any command on data type, it just takes the default value to be float. Okay, or else here in the next example, you can see that it has been provided with a data type. D type is equal to int. So it prints a 3 cross 3 array in terms of a integer value. Whereas if I'm not specifying anything, it just gives me the output in the data type float. The next is I function. I function is also similar to your identity function. It is also used to create the ones on the diagonals and other places as 0. Now let us see about the syntax. Okay, numpy dot I, that is np dot I, n comma m. So n will represent the row, m will represent the column, and the third component is going to be k. K represents the index of the diagonal. The next is your data type, whether you're going to mention it as default, means it will take it as float, or you want to mention it as integer or any other type. Whereas this order, it represents the memory layout of your array. Now let us see with an example. Now I have given np dot I of 2. So it just prints the array of 2 cross 2. Suppose if I am giving I of 3 cross 3, it just prints the array of 3 cross 3 with the data type float. Here in the second case, I have given the data type as int. So it just specifies either a 2 cross 2 array, okay, or if I am giving 3 np of I3 means it prints a 3 cross 3 array with the data type integer. Now we have given np dot I of 5. So it has to print a 5 cross 5 matrix of ones and zeros with ones on the diagonals, and it is the data type has been specified as integer. So that is not a problem. So it is going to print the output in integer. Now I've given k is equal to 2. So that means it shifts the rows, that is, it shifts the columns by 2, 0, 1, 2. It just specifies the index, and from these places you can use it. Okay, so whereas identity function, it is mainly applied for a square matrix. Okay, but I want in certain places alone one as per my application. Okay, so for a non-square matrix, we can go in for your I function. That is the main difference. Now here it is the same code, but here the value taken as k is equal to minus 2. So what does this infer? This means after two rows you are just putting the values, starting the ones, just pushing the two after pushing the two values. Okay, so k is equal to minus 2 means from here the diagonal values are getting printed. So thus now we'll see the difference between the I and identity function. So this identity function always it is used for a square matrix, whereas I you can use it for a square or a rectangular matrix. So this diagonal offset that is possible, you can see this diagonal offset is possible in this, whereas in your I function it can be supported with the k parameter. Then as far as the syntax is concerned, here it is used for the simpler syntax, whereas here it is used for more flexible with additional parameters. In a use case, it is usually for an identity matrix. We'll just go in for an identity, and if you want to create a general purpose diagonal matrix, then you go in for a I function. Thank you.